In this lecture, we're going to talk about the heart of information visualization, data types and visual mappings. So the central problem in order to visualize data is quite simple. We need to map data sets to visual attributes. This is also known as data encoding. And the process can be described in a very straightforward manner. 1, you classify your data types, and 2, you determine which visual attributes represent data types most effectively. Of course, the devil is in the details. Let's start with data types. There are 3 basic data types: nominal, ordinal, and quantitative, which can be further subdivided into interval and ratio. I'm going to explain each of these on the next slide. So nominal data can be thought of as labels or names. An example is fruit. Apples, oranges, peaches, pears would be described as nominal data. Ordinal data has an order associated with it. So for example, the quality of meat might be described as grade A, grade AA, grade AAA. There is an implicit order, so you can clearly say that grade AAA is better than grade AA. Of the 2 types of quantitative data, interval data is where the location of 0 is arbitrary. So dates are an example. If you're looking at January 5, 2012, or location, for example, latitude 47, longitude 122. And these are like a geometric point. You can't compare them directly, but only differences, that is, intervals, can be compared. And then finally, you have ratio data, which is where the 0 is fixed. And you can think of this as any physical measurement, length, mass, counts and amounts. The origin is meaningful. Let's talk a little bit more about the differences between nominal, ordinal, and quantitative data. Sometimes it's not immediately clear, given an example, what data type that it falls into. So one of the best ways to actually identify data as nominal, ordinal, or quantitative is to look at what are the operations that are permitted on this data. So nominal data, there are really only 2 operations that are permitted, either equals or not equals. For example, with fruit, you can say that oranges are not equal to apples, and apples are equal to apples. There's no other comparison that can be made. You can't say that oranges are somehow better than apples. Ordinal data has additional operations besides equals and not equals. You can now say that one is greater than or less than another, or greater than or equal to, or less than or equal to. So for example, with the grades of meat, you can say that AAA is better than AA, and vice versa, greater than, less than. You can deal with that implicit ordering. Now moving to quantitative data with interval data, for example dates, now you can subtract. So you can measure distances or spans. You can say that not only is January 6, 2012 after January 5, 2012, but you can say the difference between those 2 dates is 1 day. And finally, coming to ratio data, where the 0 is fixed, now you can add division or ratios. You can measure ratios or proportions. So for example, if an object weighs 32 grams, you can say that it weighs twice as much as another object that weighs 16 grams. All right, so that's the theory. Now let's put it into practice with an exercise. I'm going to show you a spreadsheet, and I'd like you to think about which of the columns in the spreadsheet are nominal, ordinal, or quantitative. So here we have a set of sepal and petal lengths and widths for 3 species of iris. The first column you have an ID number, then a case number, next a species number, then a species name, the organ, petal or sepal, the width and length of that organ in millimeters. So why don't you take some time and think about which of these are nominal, ordinal, and quantitative. You can see that it's not as straightforward as it might appear in the first place. For example, we have numbers here that fall into the categories nominal, ordinal, and quantitative. So let's explain why each of these is defined the way it is. So the quantitative is probably the easiest. The orange data, the width and the length of the sepal and petal, are quantitative. You can say, for example, that for the first species, the length is 7 times the width. So you can perform ratios and proportions. So it's quantitative data. Now, the first 2, the ID number and the case number, are ordinal. So why are they not quantitative? Well, because it's really not something where you can say that the distance between the ID number 3 and the ID number 2 has any meaning. But it clearly has an order. The ID numbers were assigned in some particular order. So therefore it's ordinal. And the cases were assigned in a particular order, but there's not necessarily a meaning for the differences between them. So the ID and the case numbers are ordinal. Now we have the species number, the species, and the organ, which are nominal. Well, it's probably pretty clear that the species name and the organ would be nominal because they're names. All you can do is say whether they're equal or not equal to each other. You can't say that the sepal is somehow greater than the petal. So those are pretty easy. But what about the species number? Why isn't that ordinal? And the answer to that is simply because in this case, the species number is simply a label. There is no order to it. It was assigned to the species simply as a labeling convention. All right, so hopefully that has been a useful example for you. All right, so moving on. We've now completed step 1 of the process of information visualization. So now let's describe how to do step 2, mapping data types to visual attributes. In 1967, Jacques Bertin, a French cartographer, made the first formalization of visual language and the first attempt at a theoretical foundation for information visualization. He identified 7 key visual attributes illustrated on the right-hand side of the page in 0, 1, and 2 dimensions. And these 7 key attributes are position, size, value or lightness, texture, color, orientation, and shape. So this is an important slide. You should probably write down these seven attributes or at least save the slide. So now that we have taxonomies of both data types and visual attributes, let's talk about how we map one to the other. So Bertin offered the following suggestions. He said there were levels of organization that you could consider. Position can be used for nominal, ordinal, or quantitative data, as can size. Now, value, or lightness, can be used for nominal or ordinal data, and perhaps for quantitative data, although it's not quite as clear. And texture can be used for nominal data, maybe for ordinal data. You could imagine a denser texture might be seen as having some order over a less dense texture. And then finally, color, orientation, and shape can really only be used for nominal data. You can't really say that one color is greater than another, or that one orientation is less than another, or that a shape, a star, say, is more than or less than a circle. And further work that involves decades of research in psychology and psychophysics have established this hierarchy of perceptual properties. Humans can detect differences in position most accurately, then length, then angle and slope, then area, then volume, and least of all, color and density. So when you're assigning these attributes to your data, make sure to choose position for your most important quantitative data and save color and density for nominal data. A final note on color. Value can be perceived as ordered, so you can encode ordinal variables. In other words, you see this strip that goes from black to white, where value is increasing. You can see that there is an order to these colors. You can also even encode continuous values with a grayscale mapping, although not as well. But hue is normally perceived as unordered, so you always only want to encode nominal variables using color. There's no order to the colors on the bottom of the slide. So this was a very brief lecture on the central important problem of information visualization. In the next lecture, we'll look at exercises where you can actually put this theory into practice.